it's been a whirlwind tour of pretty much all of India. You've been to the south, Chennai, Bangalore, did you Bombay? Mumbai, and now Delhi. So my first question is, and I'm sure you've met with the who's who within the AI community of India. What are some of your biggest takeaways? I mean, what was the aha moment for you, and what are you worried about?
In general, or about India?
About India.
About India. Okay.
The AI ecosystem in India.
Right. So what I'm really struck by is the enthusiasm of young people in India for technology, for AI in particular, because AI is kind of the coolest thing you can do at the moment. I was at a hotel in Mumbai Monday, just relaxing in the lounge or something, and two separate people came to me and wanted to take a selfie with me, and then telling me, I have a startup on AI and we're doing blah blah blah, and we're fine-tuning Llama and doing awesome stuff. So thank you so much for your position and Meta's position on open source. It's creating an industry, and I see the evidence for that industry in India being really kind of flourishing. I was just earlier today at IIT Delhi, and there was a crowd of eagerly enthusiastic students lapping up all the words we could say. A few days ago, I gave a talk at IIT Madras, and similarly excited population. I mean, people who, I'm sure are very talented. There's certainly a lot of interesting research coming out of Indian universities and labs. I think, and so that's the hardest thing to get, is a educated, talented population. And at least at the undergrad level, India has a good handle on this. What's missing a little bit is two things. A motivation for young people, talented young people, to pursue graduate studies on the topic, not just masters, but also PhDs. And too often in India, that's done abroad. And too often they don't come back. So giving opportunities for young, ambitious, talented, future aspiring scientists to pursue graduate studies in India and stay in India is important. And for this to occur, young people need to have some hope of a fulfilling job in research in India. So right now, the choice for this is fairly limited, and I have personal experience with this because I was in the same situation 40 years ago in France, okay, where you can certainly go to academia, but that's a particular choice that is not appropriate for everyone. You can do a startup, you don't necessarily need to do a PhD for that, although it helps. But other opportunities are research positions in industry. And that is very rare in India because companies in India are not actually, don't have it in their culture yet to do research in the style that is done today at FAIR or at Google Research to some extent, at Microsoft Research in the recent past, and then before that at Bell Labs, Xerox PARC, and IBM Research. Okay, there is this tradition of doing ambitious research in industry, publishing it, not being too possessive about IP, not being too secretive, and that culture does not exist very much outside of the US. Even in Europe, you don't have that very much. So the best industry research lab in Europe are all American companies. They're basically Meta and Google, and a couple others. So that's kind of missing in India, and the importance of this is that if you have this prospect for careers for young, talented people in India, they will stay in India. They will do a PhD, they will stay in India. They may not get a job at the top research lab, but then if that doesn't work, they'll do a startup or something. That will lift the ecosystem. Now, I speak from experience here because 9 years ago, we created a branch of FAIR in Paris. which has now about 100 people. FAIR, total around the world, has 500 scientists and engineers in 7 sites. The 3 biggest sites are in Paris, New York, and Menlo Park in California. The 4 smaller sites are in Seattle, Montreal, London, and Tel Aviv. And we have tiny ones in a couple other places. But the existence of FAIR Paris basically put in the mind of young French students and European students, like, I can have a career in research. And not necessarily be a public servant in a university, because that doesn't fit everyone's desires. And as a result, not as a result, but one thing that we did also at FAIR Paris is that we have a program of hosting resident PhD students. So at any one time, FAIR Paris has 40 to 45 resident PhD students that are co-advised by someone at FAIR and someone in a university. And so a PhD in France is 3 years, because you have to do a 2-year master's before, and which means we're graduating about 12 PhDs in AI every year. And basically that just totally jump-started the ecosystem in France. And now Paris is the hottest place for AI startup outside of the US, essentially. Yeah. So that template could be applied to India.
No, I think you've gone to the heart of the problem, and it's absolutely one of the biggest concerns we have, which is how do we, as you rightly said, we don't have the mindset for hardcore R&D in India. I mean, it's surprising to see that all the people who are really building AI, whether it's Llama or you look at any company, are from India, mostly, right? And it's something for us to really think about, is how do we ensure we create an environment where they stay back and they can build these wonderful technologies in this country. So I think that's a very astute observation. So let me switch tracks a little bit. Right now we are living in a world where there are almost 2 parallel truths coexisting. On one hand, everyone believes that AI is the best thing possible. It's one of the biggest transformative forces, and that's absolutely true. On the other hand, there's also increasing concern about the ROI. Given the investment that we are making in AI and the investments are mind-boggling, where is the ROI? And will we ever see the ROI? And I think both are correct in a sense. So where do you stand in this debate, and what's your take?
So it's very difficult to estimate what is the reasonable level of investment in AI technology. I mean, certainly there are, we hear, I guess there is a famous phrase used by a former director of the Federal Reserve, irrational exuberance, right? He was talking about a stock market bubble, basically, or real estate bubble. I'm not saying there is a bubble in AI. There's certainly a very high level of investment, because a lot of companies have a fear of missing out. A lot of investment companies have a fear of missing out. And so a lot of investment are going to a lot of companies. I think at some point we're going to see a bit of a more sort of realistic renormalization of the fact that a lot of those companies probably are not viable, or maybe are viable but not at the level of spending that they are currently doing. Like, for example, some companies have been formed with the idea of training their own foundation models. And I think it's personally that it's a very difficult thing to do for a company that doesn't have a large source of revenue from other sources like Meta and Google or Microsoft. If you're a startup and you want to be at the top level to train a foundation model, you might raise $1 billion, but you're going to run through this $1 billion in 2 years. And then are you going to be able to generate the appropriate level of revenue that justifies your valuation within that time frame? Not clear. So, I have a lot of friends running those companies. I don't want to discourage them. I don't want to say that they're going to fail. But certainly there is, some sort of estimate to do there. What a lot of people are finding is the same thing. It's the same scenario that occurred in AI in the in the 80s and 90s, the late 80s, where in the 80s there was a lot of excitement about rule-based system, expert systems. And, you know, the hardest job was going to be knowledge engineer. You were going to sit down and talk to human experts about medicine or computer systems or whatever, and then reduce all that knowledge to a bunch of rules and facts, and then feed this to an inference engine that would be able to kind of solve problems for people. And that turned out to be partially true, but also extremely difficult and expensive to do on a case-by-case basis. So reducing the human knowledge to a bunch of rules turned out to be almost impossible most of the time. And for the situation that for which it was possible, it was expensive, which means the number of applications, the size of the market for this was much smaller than people envisioned. And so most companies went bankrupt. They worked for a while and then they went bankrupt. Companies that built hardware for this AI system, Lisp machines, eventually went bankrupt in the early 90s. So you're going to be careful, right? Reducing to practice, making systems. You know, the similar scenario that occurred with autonomous driving, where 10 years ago, people were super excited. You know, there was demos. You know, you could train a neural net to drive a car for 10 minutes on complex road, and that was really impressive. And you had lots of demos like this, lots of companies that were created around this idea, and lots of even amateurs who would do this, right? I mean, it was kind of relatively easy to do. But then what was hard, and we knew that, was that to make those systems sufficiently reliable that you can actually deploy them is really, really, really hard and expensive and requires enormous teams of engineers and to take care of all the corner cases and everything and productize it. And as a result, there's only a handful of companies that can do this today, right? It's Tesla, NVIDIA, and Mobileye, and you know, a couple others. NVIDIA works with Mercedes, Mobileye works with BMW and other companies. And then there are, you know, separate companies that work on robotaxi, and that's a completely different set of technology like Waymo and Cruise. They don't actually use the same kind of techniques. They need the environment to be completely mapped. They use, you know, sophisticated LiDAR sensors and things like this, and they engineer everything out of it. And so it's not really practical for like a consumer car or anything. So, you know, those things turn out to be more difficult than you envision from an impressive demo. And there's a lot of that going on in AI. There's kind of a similar story for IBM Watson. Remember IBM Watson? So IBM Watson was going to be deployed in every hospital. It was going to help doctors. Yeah. That turned out to be really difficult. Yeah. Like just productizing that, making it useful, reliable. And that business essentially failed, and IBM sold it for parts and is not doing it anymore. So, you know, making a product out of an impressive technology is not simple. So what I'm counting on, so companies like Meta and Google, you know, have enough funds to kind of keep funding this for a while. At some point, they might get tired if we don't make significant progress, which is why we have a pretty aggressive plan for, you know, the next generation AI system.
Is there a plan B? Do you all have a plan B?
It's hard enough to find a plan A.
Fair enough.
Okay, I mean, we have two plans. We have A and A star. You know? Okay, as I said, we have a short-term plan, which is just keep improving the current paradigm, right? So LLM with, you know, flourishes and decorations on top of them to help them kind of, you know, for current use cases. And then other things like, you know, image and video generation, audio generation, image recognition, interpretation, video, etc. The long-term plan is more of the type that I was talking about with those JEPA architecture systems that really can plan and reason. It may fail.
So on that note, since we have a lot of founders here, and I'm sure all of them are dreaming to become the next big thing in AI, how do you disrupt? What's your advice to the founders who are trying to build their companies, who are trying to find their niche? What's the secret sauce to differentiating in AI, to building your moat without having to burn the kind of, you know, dollars that big tech is doing?
Okay, trick number one, use open source engines. Because you're not going to train your own foundation model if you work in the context of language, right? If you work on other things like AI for science, for materials, for for image understanding analysis, etc., you don't need an LLM. You need other foundation models, and we have them now, and Meta is also producing them. So we have a system called SAM, Segment Anything Model, and that system, basically you feed it an image, and it can basically delineate every object in that image, and you can control it in some way. That's really useful for a lot of applications in biology, in environment protection, in medicine, in all kinds of domains. There's another system called Dino, D-I-N-O, Dino or Dino, depending on which side of the Atlantic Ocean you're on. Dino V2 in particular, and that's a generic feature extractor for images. So if you have, I don't know, a quality control, you need a vision system that can tell you, analyze satellite images or tell you whether a thing that you just produced in your factory looks good or not, or is defective or something. You can just run Dino, extract the features, and then train a very small classifier on top with very, very little data to actually get the result you want. So that really, really simplifies the construction of computer vision systems by reducing the amount of training data you need for that. So, use all the tools at your disposal, and don't try to build everything from scratch, and just profit from open source. That's trick number one. Trick number two, I think a lot of the business is into customization of things like LLMs or other systems for vertical applications. There's a lot of work to do there. A lot of companies that know they want to use AI but have no idea how. And so there's a whole ecosystem of startups that basically cater to those kind of needs, right? That's really the type of ecosystem that open source platforms really enables, right? And everybody I've talked to here who is a founder or member or engineer in a startup, they all use open source platforms. Most of them use Llama. Many of them use Dino or SAM. Yeah. All the ones I talk to in Europe also are based on this. And increasingly, a lot of large companies do this. I was at the Infosys headquarters yesterday, and they use Llama for all kinds of stuff for their clients, big companies.
Oh, absolutely. By the way, if any of the founders have a really good question to ask, let me know. I'll be happy to take one or two questions if time permits. My last question to you, Yann, is as you think about the next 10 years, what do you look forward to the most? What excites you? As you rightly said, I think AI is still in an evolutionary stage. There's so much left to happen. We've been hearing about agents, etc. So what is that one breakthrough that you're really watching out for, you're really interested in?
That breakthrough is this type of architecture I was talking about, the JEPA architecture, systems that understand the world, can plan, have persistent memory. This is the mission of FAIR, right? We have a few hundred people. Not everybody at FAIR works on this plan, but we basically have a few hundred people kind of focusing on making this work. And the potential success of this is really what excites me most. I'm really a scientist at heart. I do technology policy and stuff like that as a hobby, really. And some people in policy at Meta don't like me very much for this, but I think it's an important hobby. Don't misinterpret what I said, but really I live for scientific progress and research, and also for the applications that can result from it. But I leave that to others very often. Very frequently in my career, I had the opportunity of, there was some scientific breakthrough, and there was an opportunity of, okay, let's do a startup, or let's work on this set of applications of this new set of machine learning techniques. And every time I kind of participated in this a little bit, but then came back to the main road, which is making machines more intelligent, right? That's really what drives me. And I'm almost as excited, probably even more excited now than I was when I was 25, because of the prospect of perhaps seeing the light at the end of the tunnel of human-level AI. I think that's an incredibly
you do see the light at the end of the tunnel?
Yeah, because we have a plan. Like we know what to build. We know it's going to be hard to figure out the details of how to make this work. But we have some idea of an architecture. I actually wrote, and all of this is public, so I wrote a long vision paper that I posted 2.5 years ago. It's called A Path Towards Autonomous Machine Intelligence, AMI. Now, we changed the A to advanced because autonomous scares people. But basically, I explained, here is where I think AI research should go over the next 10 years. And you're welcome to join us. Like, this is no single entity as big and prestigious as it is has a monopoly on good ideas. There's a lot of problems that we have to solve to make progress there. And so basically, that's an invitation for the entire scientific community around the world to collaborate on this. And it's kind of succeeding in some ways. A lot of people are working along the same ideas. But of course, people have their own ideas, and they should explore what they think is most promising. So this is really what excites me the most today. And then on the application side, the potential applications of AI in science and medicine, I think, are enormous, and I'm really excited about this. So I participate in this a little bit, but not to the same extent.
Thank you so much, Yann.
Thank you
for being so generous with your time and your knowledge, and I think it's given the number of founders in this room. I think that'll be really helpful. So we do hope you'll come back again. You can see how interested people are to speak to you. So I do hope the frequency will increase. But thank you again for an absolutely wonderful conversation.
Thank you so much.
For more content on tech and leadership, subscribe to NASSCOM YouTube channel and press the bell icon to never miss an update.